Let me tell you a story. This story is about two spies during the Second World War. One is in London, the other is behind enemy lines in occupied France. They need to communicate, orders, intelligence, locations. But every message has to pass through enemy territory. Every letter can be intercepted, every telegram can be read. And if the enemy reads the message, the operation fails. The spy dies. The war could turn. So they create a language, a code, private, unbreakable. The enemy intercepts the message. They hold it in their hands. Every letter, every word, every sentence. But they can't read it. Because the message is in a language only two people in the world can speak. This secret language, this code that turns meaning into nonsense, this is encryption. And it is how every secure conversation on the internet stays private. Here's how it works. When you send a message, an email, a text, a password, encryption scrambles it. It takes your readable message and transforms it into complete gibberish. Meet me at the cafe at noon becomes like what you see on the screen. Meaningless, unreadable, unless you have the key. This key is like the code book the spies used. It is the only thing that can turn the gibberish back into the original message. The enemy can intercept your encrypted message. They can look at it, study it, even try to decode it. But without the key, it is just noise. Encryption doesn't hide your message. It makes it incomprehensible to anyone who doesn't have the key. Let me show you how this actually works. Encryption has three components: the plaintext, the algorithm, and the key. The first component is the plaintext. This is your original message, readable, clear, unprotected. Transfer $10,000 to account 4729. That is plaintext. The second component is the algorithm. This is the mathematical process that scrambles your message. Think of it as the rules of the secret language. How letters map to other letters, how words transform. Common algorithms include AES, RSA, Cha-Cha-20. Each one has different rules for how it scrambles. The third component is the key. This is the critical piece. It is a unique string of data, usually a long random number, that the algorithm uses to scramble your plaintext in a specific way. Same plaintext, same algorithm, different key, completely different output. Your plaintext goes through the algorithm using the key and becomes ciphertext, the encrypted message. Transfer $10,000 to account 4729 becomes like what you see on the screen, the ciphertext. Gibberish until you decrypt it. To decrypt, you take the ciphertext, run it through the algorithm with the same key, and get back your original plaintext. When you visit a website with HTTPS, that little lock icon in your browser, your connection is encrypted. Every request you send, every password you type, every credit card number you enter is scrambled before it leaves your device. Plaintext, algorithm, key, ciphertext, that is encryption. And the key, that is everything. Now, here's the beautiful thing about encryption. It is not new. We've been encrypting messages for thousands of years. Julius Caesar scrambled his military orders using a simple cipher. Shift every letter three places. A becomes D, B becomes E. World War II brought us the Enigma machine. Mechanical encryption that took years to break. Because here's the truth. Humans have always needed secrets. Privacy isn't a modern invention. It is a fundamental human need. We've always wanted to say things that only certain people can hear. We've always wanted to share information without sharing it with everyone. Encryption is just the latest chapter in a story as old as language itself. The technology changes, the algorithm gets stronger, the keys get longer, the principle, the same. True privacy isn't hiding the message, it is making sure that only the right people can understand it. So remember, the enemy can see every letter, but they can't read a single word. That is encryption. File closed. Next case, shadows in the machine.